In this video, we will talk about while loops. Loops in general allow you to take a block of code and repeat it multiple times. And in Python, there are two types of loops, the while loop and the for loop. We'll talk about the while loop first, and then in the next module, we'll address the for loops. I want to begin by motivating the concept of loops with an example. Here we have a Jupyter notebook, and it starts with "Welcome to the number adding problem. Enter a number to add or type stop." Okay, this is generated by a cell of code, but I don't want you to see it yet. We'll get to that. I want you to focus on what the program is doing. So let's enter a number, 7. Now it says total 7, and then it repeats itself. Enter a number to add or type stop. Okay, another number, 4. Total 11. Okay, I see what's going on. It is carrying a running tally of all the numbers that I enter. So let's see if I enter a fractional number, 6.1. Now it says 17.1. Very good. How about negative numbers? Negative 9.5. And now it says total 7.6. Excellent. What happens if I say stop? As expected, the program stops. What I want you to notice here is that this program could not have been written with purely sequential code. That is because we do not know a priori when we're writing the program how many times the user is going to want to repeat this block where we prompt the user for a number and then we update the running tally. That in this case was 4 times, and then the last one was stop, but it could have been any number of times. So at the time when we are writing the code, we wouldn't know how many times to copy paste that block of code. We need some sort of looping mechanism to achieve this. While loops are one of 2 looping mechanisms in Python, the other being the for loop. So this diagram illustrates how while loops work. A while loop executes a code block as long as a Boolean expression remains true. So you have your interpreter, it's coming along evaluating lines of code, and when it encounters the while loop, the first thing that it's going to do is evaluate its Boolean expression. So if that Boolean expression evaluates to false, then the interpreter will take this path. That is, it's going to skip the code block in that while loop. On the other hand, if the Boolean expression evaluates to true, then it's going to evaluate that code block. And remember that a code block can contain within it many lines of code. So once the interpreter is done with that code block, it's going to go back and it's going to reevaluate the Boolean expression. If the Boolean expression is now false, then it's again going to take this path and it's going to be done with the while loop, and it's going to carry on with the rest of the code. However, if the Boolean expression is true, then it's going to reevaluate the code block. And it's going to continue to do this, reevaluating the code block as long as the Boolean expression remains true. So here is the syntax for creating a while loop in Python. You begin with the while keyword, and then you follow that with the Boolean expression. So just as with if-else clauses, that Boolean expression can be a simple Boolean expression, a compound Boolean expression. It can be just a Boolean variable. It can even be a function that returns a Boolean, just anything that evaluates to true or false. And then you follow that with the all-important colon, and then comes the code block, which again is indented with respect to the while keyword. There are 2 additional keywords associated with looping in Python, both for loops and while loops, and those are the continue keyword and the break keyword. So continue instructs the interpreter to skip the rest of the code block and go to the next iteration. You can put continue anywhere inside of your looping code block, and when the interpreter hits that line, it's going to ignore everything that follows it in the code block and go straight back to the beginning and evaluate the Boolean expression. And from there, everything proceeds as before. If it's false, then we're done. And if it's true, it will start the code block from the beginning. Now, usually a continue will be within an if clause that gives a condition, this Boolean condition, under which you would want to do this continue. Then we have break, and break does something even more drastic. When we hit a break, it's going to immediately break out of the while loop and continue then with the rest of the code. So it breaks out and joins the false path, and it's done with the while loop. Again, a while loop is a break is usually put within an if clause that gives a condition under which you want to perform the break. So that's pretty much all there is to know about while loops. Let's go back and see how the number adding program was implemented. Okay, here is our number adding program. And you can see that it begins by printing a welcome message. It does that by invoking this print built-in method and passing into it a string. So we've already done this several times, but I've not yet focused in on what strings are. So let's do that now. So a string is one of the native or built-in Python data types. So it is in that original diagram, and it's on the side of the collections. So str, the string data type, is strictly speaking a collection data type. And we'll have opportunity to talk more about strings later when we talk about collections. For now, all I really need you to know is that to create a string, you can use either single or double quotes. So here are some examples. I can say print and then just pass in a string. This string, and this one is defined using single quotes. This is a string. Strings can contain any character, including numbers, different symbols, and even if you provide the code for an emoji, it will print the emoji. Some people prefer single quotes. It's really up to you. It's a matter of style, whether you demarcate your strings with single or double quotes. You can actually mix the two. So if you need to include double quotes in a string, well, that string should be created using single quotes. So that, because if you put a double quote here, then this double quote would be closing the string. So if you need double quotes in a string, then create that string using single quotes. And vice versa, if you need single quotes in a string, then you should create that string using double quotes. Okay, back to the code. Following the welcome message, the program then defines a variable called total that it's going to use to track the sum of the numbers. And so it initializes that variable to 0. Then it's going to prompt the user to enter the first of the numbers in the sum. And it does that with this built-in method called input. Input is the one that is going to create this little prompt and then wait for the user to enter some string, be it a number or be it stop or any other string. And then once the user presses enter, it's going to assign that string to this variable that I've called add string. And then we reach our while loop. So the while loop, you notice here, the Boolean condition is that we will execute the code block as long as the add string, that is the value that the user has entered, is not equal to stop. If this is false, that is, if the add string is equal to stop, then this will be skipped and we will continue with the rest of the program, which in this case is non-existent, so the program will stop. If this is true, in other words, if the string that the person entered is not equal to stop, then the program will take that string and pass it into this function called float. Now this is another one of the built-in functions. It is one that I categorized as type conversion in that original slide about built-in functions. Let's take a moment now to talk a little bit more about type conversions. You'll recall this slide with the built-in functions, and we've already covered print and input. Now we're going to talk about the type conversions for int, float, bool, and string, and also these type checking built-in functions. Let's do it in a Jupyter Notebook. Let's say we define three variables, a with value 4.3, b with value 3, and c, let's say it's a string with value hello. And now we want to check what are the types of each of these variables. For this we have the type built-in method, and we can pass into type, we pass in a variable or a value, and it tells us what is its type. So in this case I pass in a, and a is a float, so it tells me float. If I pass in b, b is an integer. And if I pass in c, c is a string. Also, we can use the built-in method isInstance. And that, instead of giving us the type, it's going to check whether that variable is of a given type. So if I say isInstance and I say C and I say string, I am asking, is C a string? And it answers true. C is a string. On the other hand, if I passed in, is C is a float? False. C is not a float. But A is a float. Also, we have the type checking built-in, or type conversion built-in methods, such as integer, float, etc. These methods convert from one type to another, and their name is simply the type that is being converted to. So, for example, if I wanted to convert a, which is 4.3, into an integer, I could say int a. That would convert 4.3 into an integer. Let's say, oh, I can do that explicitly, 4.3 to an integer. It does it by basically truncating the decimal part of the float. So if I did 4.9, that would still be 4. And if I did negative 4.9, that would be negative 4. I can also convert numbers into floats. So if I have an integer, a 4, that becomes a 4.0. It's now a float. I can also convert, say, a string into a float. If I have 54 as a string, I run that and it gives me the numerical value 54.0. I can also convert things into strings. Say, I can convert a number into the string for that number. One has to be a little bit careful with these things because, for example, if I pass in a string that I want to convert into an integer, this will work. However, if I put something that is not, strictly speaking, an integer, that's going to lead to an error. So use these type conversion methods with some caution. Okay, back to the code. We now know that this float method is going to translate add string, which is a string that was provided by the input method, into a float, which we call add. And then we add that amount to the running total, and that's the new total. And then on this line, it's going to print the total. So this is a so-called f string. And we'll learn more about f strings later. Essentially, this is just printing the total amount. Then finally, we are going to ask the user for a new add string. And then we're done with the loop. It goes back and it checks whether that new add string is equal or not to stop. And if it's not equal to stop, then we repeat the block and we continue in this way. One thing I want you to notice is that this line is identical to this line. What I'm going to show you next is a way of implementing this same program in a way that avoids the repetition of lines and makes use of the break keyword. Okay, here we have the two versions of the code. The first one, which is the original one that we've already gone over, and now a second one. The first thing you'll notice in the second version is that the condition for the while loop is set to true. Now, why is that? Well, let's go back to the first version and remember that the condition in that case was add string not equal to stop, so we had to query the user for add string before reaching the while loop. And then, of course, we had to query them again within the while loop, and hence the two identical lines of code. Now, when we set the condition to true, that's essentially like leaving the door open so that the code can enter the loop for free. And then once we're inside the loop, we can query the user. And then we add this clause, which is checking whether the user has entered stop, and if so, break out of the while loop. Now, imagine what would happen if we didn't have this clause. In that case, there would be nothing to stop the looping, and we get what we call an infinite loop. And now that's bad news, because a program that has entered an infinite loop can only be stopped by killing the process, so not good. So we need this clause. And then after that, these three lines are just identical to these three lines. So this pattern of using a true and a clause for breaking that is identical, has an identical result as this pattern is actually quite common. And it's really a matter of taste what form you use. Now, one thing about while loops is that there is this danger of having an infinite loop. So unless you really need it, while loops are not that common, and people tend to use for loops much more than while loops. But in a situation like this, it really is necessary.